Welcome to Starter Pack. All right, so everybody's obsessing with AI with bigger, faster, stronger models, right? Well, luckily we're starting to see that is actually being proved wrong. I've been talking about that for a while here on my channel, but we're starting to really see that this is not the bigger, better, faster. Faster, everybody wants faster, but bigger, better, and more hardware is not the only way to solve AI, right? Today I'm going to dive in and tell you why I think small language models, or SLMs, are better than their larger counterparts. LLMs try to solve absolutely everything, right? But smaller AI models are the unsung heroes of the tech world, and they're really starting to change the game for startups and for developers. So stick around because we're going to talk about this and about what we're seeing with a big shift with these small language models. And let's dive in today. Welcome to Starter Pack. I'm Spencer Thomason. Here at Starter Pack, we love to train software developers in our licensed coding boot camps, as well as to build custom software solutions for companies. As a fractional CTO of over a decade, and with over 25 years of software development, I've mastered transforming tech teams and products. All right, so why is small language models better? Now, we're going to break this down for you today, but big language models are like gas-guzzling SUVs, right? They're impressive. You can carry the whole soccer team, right? But they're totally overkill for when you're just needing that day-to-day commuter, right? And that's what small models are, right? They're this little electric, like just a tiny electric motorcycle of sort, nimble, efficient, and perfect for getting the job done without breaking the whole bank. So you can see why there's a lot of people who are really interested in these small language models, right? Small language models are better because they're more cost efficient, right? Rather than running these massive models that require hundreds of millions of dollars to train and even millions and millions of dollars just to even be able to run. Startups don't have this kind of money, and it gets really tough to be competitive into an AI space when your bare minimum bill is $10,000 to $20,000 a month on GPUs, right? So one of the great things about this is you can actually do it with less computation power, right? You're able to stand up a server yourself, put some hardware for $1,000, $2,000 into some hardware, and actually start proving out a project, right? So smaller models doesn't mean that you can't experiment. It means you can experiment without having to burn the whole bank, right? One of the biggest problems, I remember the very first time I spun up a cloud server, and I looked at the cost and I was like, this thing's going to cost me like $10,000 a month to run. Whereas these smaller models, you can do a lot of proof of concepts and a lot of your development right in-house, and even run efficiently enough on a small production server on a small scale. Now, if you're trying to compete head-to-head with DeepSeek or Microsoft or one of these others, that's a totally different game. But I'm talking about for you entrepreneurs that want to put AI to use and build something so that your company can start to build a product, or you can build an internal tool that you want to be able to use, right? These small models process data faster because they're optimized for a specific task. So they don't waste a ton of resources trying to find every single instance of this in the universe. They're looking for just this one thing that they can be optimized for, right? It's about the difference between using a sniper rifle and a shotgun, right? It's precision over power. You want to have faster processing, and that's going to mean that it's going to get an answer back quicker. But at the end of the day, it doesn't have to try to eat the whole elephant, right? It can just eat its toenail for just what you're trying to do. So slow and steady does not win the race here. You want to get something that's faster. But the bigger models are like trying to steer a cruise ship, right? You can't really make sharp turns. These smaller models are more agile and adaptable. So you can use these for training small notebooks. A notebook is a set of data that you have internal. So think of if you have an internal set of documentation and you want to be able to train your AI on it, you can use these small language models and train them on it and build a notebook or notebook LM and then train on it, also while still being able to use a small model, right? So that it can do the empathy and all that kind of stuff. Now, if you want it to be able to understand your industry's jargon, you can feed it and train it on these things. And so it's kind of like having a custom tailored suit instead of one off the rack, right? The large one is the one off the rack. It's going to be one size that could fit a lot of people. The small one is going to be custom tailored to exactly what you need. Now you're seeing a lot more shift toward this because this is where we're hearing talk about agents, right? If you hear the word AI agent, this means they're using a smaller model that's been optimized for a specific use case, right? So this smaller model means that you can innovate and develop it right in-house. Now I want to show you some examples of some of these smaller models because they're super accessible, right? That's one of the other things too. It seems like everybody's giving these ones away. And so they're great to be able to have people be able to see. So we can see here that this one's Microsoft's, right? So this is Microsoft's small model. Their small model is the Phi series models. Now, The 5.4, they only released in 14 billion parameters. So the way that you're figuring this is you want to do 1.2 times the amount of GPU memory you have. So if you have 14 billion parameters, you're going to need 1.2 times this. So you're going to need probably a pretty solid 24 gig graphics card, which you can get for about $1,000 right now. I was just looking last night. You can find a pretty solid 3090 for $1,000, which would comfortably run this, right? Because at 24 gigs of RAM, right? If I pop open my calculator here, right? I'm not super good at, 1.2. So, it's going to be about, you need 18-ish, roughly around 18 gigs of GPU RAM in order to be able to process this. Now, the other thing is you can actually build out a server and use it in memory too. It's a bit faster to do in the processor, in the GPU. GPUs are going to process faster, but again, you can't even, and on these small models, you definitely can if you have enough RAM on the machine too, right? Now, one of the things that's interesting about this is that, when Microsoft released this, they have the 3.1, which only has 8 billion parameters, and they even have a 3 that's 1.5 billion parameters, right? So you can see that they're playing around with a lot of these small models, right? And so even when they announce 4, you go to the link that says, hey, for 5.4, and it's interesting because one of the videos is on 5.3. So 5.3 is actually still plenty, a plenty good use case because 5.3 has a 1.5 billion processor. So that you can do on pretty much straight RAM plus CPU and at least be getting some interesting dev. For Llama, you're talking about Llama 3.2. Llama 3.2 has 1 billion or 3 billion model parameters, and then they have multimodal, which is 11 and 90. Now, again, we're talking about the small ones here, so I'm really interested in the 1 billion and 3 billion parameters. This is enough that you can still run this on even GPU with VRAM, or a really inexpensive. I was looking last night for $179. You can get a 6 gig graphics card, which will comfortably run the 3 billion model parameter. Any piece of hardware, under $200 for a graphics card, boom. It's under $500, you're up and running and you're developing on AI, right? DeepSeek now also just helped change the game, of course. We're going to have to talk about DeepSeek if we're talking anything about AI right now, right? So DeepSeek R1 just came out with a 1.5 billion model, right? So this is actually the link that I have here is the 1.5 billion model, right? So you even have a 1.5 billion model from DeepSeek. Again, this can be run comfortably in RAM. I'm actually working on a video right now where I'm going to show you how to run it on a Raspberry Pi. So this does not take a lot of computation power to be able to run these. So you can see that this becomes something that you can very easily run with just the computing that you have pretty much lying around, right? Especially if you have a gamer friend, because I guarantee they have an old gaming rig that you'd be able to put to use for this. So the big models can memorize data instead of learning it, but smaller models are going to be generalized because they can be generalized to specifically what you need. You can run them inside an agent, run them in the background, and have them become very repeatable at what they're doing. And so it's also easier to debug with these smaller models. You can get them to train and get them honed in much better. You can ultimately get them dialed down right to a niche for an application. So small models really are a great way for you to dive in and get started and dip your toe if you want to start doing development. Smaller models are paving the way for democratized AI. They're also making AI accessible to everybody because, as you can see, I just gave you an example of 4 of the most popular small. This is David versus Goliath, and David definitely can throw a stone and hit a very precise spot. So I really think the future is small, efficient, and powerful. Every time you hear the word AI agent, this is what's going on. They're using an agent with a small model to train inside of a limited set of capacity to perform a specific task. Now, what do you think? Do you agree? Do you disagree? I'd love to have a great discussion, so make sure you reach out, because here at Startup Hack, we love to train software developers in our licensed coding boot camps, as well as to build custom software solutions for companies. So reach out because we'd love to help. Otherwise, we'll touch you guys, and here's a great offer.
Want to become a software developer but don't want to spend 4 years in college and rack up massive student loan debts? Think you need technical expertise to get started? Welcome to Startup Hack, a better way to start your software career without student loans and years without income. One-on-one tutoring is included so you never get stuck and have guidance through the whole process. No technical experience is necessary. Learn at your own pace and in your own space. Startup Hack has worked with local state agencies in your area to make it so that qualifying students can get the program costs covered entirely and students can start earning while they learn. Complete our 3-month coding bootcamp, gain hands-on experience, and land a paid internship. With 2 years of experience on average, our graduates are making over $80,000 per year. The 3-month program includes technologies from Microsoft, Google, and Facebook. No debt, just a quick path to earning. Check out startuphack.com to code your future and start today.